You are watching the 7.3 lesson video on piecewise functions. So piecewise functions are very similar to the step functions that you looked at in 7.2, only now we are piecing together different functions. So we're going to take like a linear function and a quadratic and an absolute, and we're going to piece them together over certain domains, over certain x values. But first, let's talk about if some piecewise relations are actually functions. And this takes us back to, what is it, Unit 2, when we talked about is something a function or not. I even think this brings you back to 8th grade. So exercise 1 says, determine if each piecewise relation is a function, and of course we should explain. So A is a function. Now, every other part of the graph looks fine. I'm just going to draw this line here because this is where we should always be careful. Now, it may initially look like it's not a function, but remember, an open point means it does not equal. So this is actually a function. And if we explain, it's because every x value has only one y value. So even this x value of 2, it may, or sorry, negative 2, it looks like there's two y values. It's not, because it really only has a value at 4. And you would have talked about this probably in the step function or even on the first day video. Okay, now in B, is this a function? Well, I see this weird jump thing happening here, and uh-oh, they're both close points at the x value of 1. So unfortunately, this is not a function. And why is it not a function? Well, the x value of, what is that, 1? So the x value of 1 has two y values. And what are those y values? 3 and negative 1. Okay, so function in A, not a function in B. Moving on to exercise 2. Now we're going to graph this piecewise function below, and I am going to do a ton of color coding. This is my one piece to my function. So a piecewise function, remember, is three, in this case, three functions, two or more functions, being pieced together. Those are my three pieces. And the domain is such a big deal. So from -6 to -3 is going to be one function, -3 to +2 is another, and then 2 and beyond is my last. Okay, so for each one of those little highlighted sections, I am only allowed to look at those three pieces. So my yellow piece is only going to be the linear function 2x plus 3. My blue piece is going to be the quadratic function of x squared minus 4. And my green piece is going to be the linear horizontal line of -7. All right, so let's start graphing here. All right, I am going to write my first part in purple. So 2x plus 3. You could use your calculator to graph, but really, I mean, it's a y-intercept of 3, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or left 2, or down 2 to the left 1, 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 and so on and so forth. I'm going to cover my entire graph, and I'm going to draw a line through all my points. Okay, oh gosh, that was terrible. Let me try that one more time. It's so hard. I don't really have like a ruler like you guys are using. Okay, good enough. So if I look at this, the one issue that I am seeing is I'm only supposed to be looking at this part of the function from here all the way to there, and that's it. I should not be looking at it anywhere outside of that yellow highlighting. So I am going to remove that part and then all of this stuff. The last thing that I need to be a little bit concerned about is that I'm using the correct endpoints. So here it's closed here is open, just like I would a step function. Here is closed, there is open. Okay, let's do the same thing now with my x squared minus 4 piece. I think I already graphed this over here. Sure did. So you could jump to your calculator. Here's my table of values for this piece. It's a quadratic, obviously. I'm going to graph this one in blue. All right, so 0, -4 was just a shift of down 4. That's why it looks like this. And remember, I'm only graphing it in the blue area, in the blue domain, I should say. So I don't need to graph anything else over here because I hit my 3, or excuse me, my -3. And I'm going to stop at 2, and it's an open point. Check it out. Not equal to. Can equal. So I could graph the whole function if I really wanted to, and then erase it. Or in this case, I'm just stopping. So if I had accidentally gone like this, I would have realized that I can just use an eraser because we're using pencils to help us. Now the last and final piece, I'll graph in green, that's when f of x equals -7. So -7 is every single one of these points here. But remember, we're dealing with all of the green area, so I don't need anything else over here. From 2 is bigger than or equal, or x is bigger than or equal to 2. Now, your calculator can graph these. I have it already graphed here. Now, the way that you graph this is you're going to go to your key next to the 9, and then you're going to use this thing that I have highlighted in blue here. It will ask you how many pieces you want, and in this case we had 1, 2, 3 pieces, so this is how we would use our technology to support us. You would definitely also want to use the control equals sign to get all of these values. Now the one thing I want to point out is, look, their endpoints are not showing, which means you need to be very careful with your endpoints, the open and the closed. So always be on the lookout for those. Now f of 1, part B, says find f of 1 algebraically. So that is really saying x is equal to 1. So the first thing that we have to identify is what part of the function is this pertaining to, yellow, blue, or green. Well, 1. X is 1. So is 1 in between -6 and -3? Is 1 in between -3 and 2? Yeah. Yes. So x squared minus 4, the blue piece, is what we need. This is just 1 squared minus 4, and 1 minus 4 is -3. And if we look at the graph where x is 1, y is -3. So it checks, and we're happy. All right, moving on to exercise 3. So a driver. Well, okay, it looks like we just have to graph the situation, right, on the set of axis below, well, to the right. Draw a graph that models the driver's distance from home. Okay, so this driver dude, or gal, it looks like, they're starting off at home, so their distance from home is 0, and then they're driving at a constant speed of 60 miles per hour for 2 hours. So 60 miles in the first hour, 60 miles in the second hour. There's my piece. Okay, then what happens? Oh no, her car gets a flat tire and she spends 30 minutes, so her distance doesn't change because she's changing the tire. But then she resumes driving and drives at 30 miles per hour for the remaining 1 hour. So 2.5 hours to 3.5 hours, she's only traveling 30 miles per hour. That's why I'm only going up to 30, or going up 30 more miles, 150. And it looks like we're done. Sorry that this graph is a little bit thicker. I drew my line a little weird and it was bugging me, and now it looks worse, so I don't know what to say about that. Okay, moving on to exercise 4. A copy shop is charging 15 cents per photocopy for orders of 20 or fewer. And then looks like 12 cents for 50 or fewer, but more than 20. And then 10 cents for more than 50 photocopies. Okay, so this looks like a bunch of pieces that we need to have. So our function is c of x. Yep, I'm totally picking up on this. And we need to come up with those 3 pieces. Okay, so what was it? 15 cents per photocopy x, and then 12 cents, and then also 10 cents. And then obviously we need to restrict the domain. So what? 15 cents is 20 or fewer. So x has to be equal to or less than 20. And then what's the next one? Has to be more than 20. Oh, this is compound. We have 20 and 50. So we have a little bit of a range of domain values. Okay, so 20 has to be more than 20. So x has to be more than 20, but less than or equal to, because it could say 50 or fewer. So less than or equal to 50. And then my last piece has to be more than 50. So x has to be bigger than 50. So here's my blue. Here's my, here's my green, and here is my yellow. All right, perfect. All right, exercise number 5. There's a typo in exercise number 5. Let's fix this first. Okay, so this should say plus 400 right in there. All right, so there's an equation. It's obviously a piecewise one, and it's dealing with weekly earnings of an employee. And the function is w of x, and x is the number of hours worked. So that's kind of important. So here it says, determine the difference in salary in dollars for an employee who works 52 hours versus an employee that works, what, 38 hours. Now I highlighted these in 2 different colors because we have to look at our piecewise function. So this is the x value they gave us. X is 52, x is 38. So if I look up above here, when x is 52, I'm using this piece to my function because 52 is bigger than 40. 38 is in between 0 and 40, so we're going to use the top portion. Okay, so let's go with this. I am allowed to use my 10x piece for 38. So what is that? 10 times 38. That's easy. That's 380 bucks that they'll make. Okay, now, I have a little bit more math to do here. 15 L times x minus 40 plus 400. Don't forget that typo that we fixed. And here we have to put in how much? 52. So 52 minus 40 plus 400. We could go through and do order of operations, or we can just make our calculator do the work for us, which I think is a little bit faster and less room for errors. So let's use it. And what do we get? 580 bucks. Okay, obviously they're making more money and they wanted to know the difference. So what we need to do here is find the difference between 580 and 380. So we're subtracting them. Difference means subtract. So how much is that? 200 bucks. Okay, so part B says determine the number of hours an employee must work in order to earn $445, and then explain. Okay, so let's think about this here. If we work, let's say, the maximum of 40 hours in a week for this first part here, 10 times 40 is 400. That is the maximum. So what we know here is this person had to have been working what I would say overtime, because we cannot get $445 ever from this blue piece because our maximum value of 40 gives us the maximum Y value of 400 for that piece. So what we had to do is use this second piece and that second piece had to have equaled 445. Now I could go through and solve for x, which I think is kind of annoying, or what I could do is just graph it and look at its table. which conveniently for me, I have already done here. So I've graphed my piecewise function. You can see this up here. And I am going to look for $445 in my table. So as you can see, my Y values are really high. I knew that I had to scroll down past 40, and we can see that at the Y value of $445, it was an X value of 43. So my answer is 43 hours. Oops, why am I putting a dollar sign? I don't know. So 43 hours is my answer. Now let's explain. So just talking through what we did here, we graphed the function and we found that the X value was 43 when Y was 445. And we could have said the X value is always in terms of hours when the Y value is in terms of money.